In this video, I'll introduce the concepts that deal with thermodynamics. So thermodynamics, that word has two parts. Thermo refers to temperature or heat, and dynamics, that's something we learned about last semester. Dynamics is forces and energy and motion. So those things are related because, well, heat is a type of energy. Energy can do work, and since we can change the energy of gases, that means gases can do work. That's what thermodynamics is about. So that means that different thermal processes, so that could mean taking a gas and increasing the temperature, decreasing the temperature. It could be changing the volume or the pressure. Doing those things can do work. So we will look at the work that's done when you do any of that. We'll also look at specific heats for an ideal gas. We've looked at specific heats for solid and liquid materials. For a gas, the specific heat depends on the conditions. If you keep the pressure constant, then the specific heat of the gas will be Cp, P for pressure. If you keep the volume constant, then the specific heat will be a different value, a Cv. We've already looked at this a bit, but again we will look at heat flowing, and you have to remember that heat tends to flow from high temperature to low temperature. If you want to try and make it go the other way, you have to put in some amount of energy to create a process where that can happen. Normally, you always go from high temperature to low temperature. We'll look at heat engines. Heat engines are things you can use to make heat go the wrong way, for example. We will also look at the efficiencies of heat engines. We'll look at cooling systems, so things like refrigerators and air conditioners, and their coefficients of performance. A coefficient of performance is essentially the same thing as an efficiency, except that coefficients of performance don't have an upper limit. We'll also look conceptually only at entropy.